Alright guys, here we go with these practice test solutions for test 5. We'll just get straight into it. The following questions refer to the data set below. Find the mean, median, and mode of the data set. Okay, so as always, we need to try and organize this data into lowest to highest first before we can do anything to it. I always find it easy to just knock it off one by one. These are the questions where you need to be really careful about, because these are the ones that are going to get you not organizing data properly. So we'll go across and we'll get rid of this 3 first, put 3 at the bottom. Let's go to the next number that's bigger than 3. Go through all of them. Next one's going to be 5. Again, let's go through all of them. Next one's going to be 8. Then we've got 2 lots of 9. So we'll cross that off. Now what's bigger than 9? 11. Then we've got 12 and 12. Then we have 13. 14. And finally 18. So now it's trying to find the mean, median, and mode of the data set. Well, the mean, let's just call it x hat. Because we're going to call it x hat a lot in this, I'm just going to use the same terminology. Is all of them added together, divided by how many there are. So it's 3 plus 5 plus 8 plus 9 plus 9 plus 11 plus 12 plus 12 plus 13 plus 14 plus 18, all divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that is going to give me 13.09. And remember, make sure your answer is clear, because I may know you're working out, but some people in exams in the future may not know you're working out. Make sure your answer is clear. The median, that's just my middle value. Luckily for me, there are only 11 data points, and so that middle value is just going to be exactly in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That means this is the middle. Your median is 11. Now the mode. We should remember that the mode is the most often, okay? Mode, most, happens the most often. You actually have 2 modes in here, and that's 9 and 12. Again, make sure your answers are clear. Construct a frequency table for the following data. Alright, now it doesn't really matter what way your data is in intervals. You could do it in 5s, you could do it in 10s. Okay, I'm just going to do 5s for this one. So we've got an interval, we've got a frequency, and then we have the percentage. Remember, your frequency tables will always have that percentage. And now when we write our intervals, we have to be very careful on how we write it. Okay, so we're going to start with 0. So it's going to be greater than or equal to 0, and we'll just put x. But it's going to be less than 5. If it was 5, it would be in our next interval. So we have to be careful when we're writing our inequalities in that interval. 5 to 10. Again, we're just going to keep going up in 5s. 10 to 15. And there are really 2 ways you could write this one. You could write it like this, so it's just greater than 15. Or you could put that limit on at the end as well, and less than 20, because there is nothing greater than 20 in our data set, but either one would be acceptable. Adding them together, we've got 1 here, we've got 4 here, we've got 5 here, we've got 1 there. Then we need to find the frequency of all of these. And I'm just going to approximate for this one, because it might be a bit annoying to write the decimals. So this is going to be around about 9%. This is around about 36.36%. This is about 45.45%. and this is about 9%. And I did that just by dividing this number in the frequency by the total number that I have, and my total number is 11, which we should know because we knew there were 11 data points in our first question. For two events, A and B, the probability of A equals 0.5, probability of B equals 0.4, and their union is equal to 0.8. We want to find the probability of the intersection of A complement and B. Now with these questions, if I can't figure out what I'm going to do, I find it easier just to visualize it. So I'm going to draw a Venn diagram. If you don't want to draw a Venn diagram, absolutely don't feel the need to, okay? I'm not going to make you draw it because it's really not necessary for the question. However, for me personally, I am a visual learner. I like seeing things. So if it's going to help you in a test, by all means, just draw it out. Well, I don't draw my circles very well. Close enough. So let's go. The probability of A is that. Probability of B is here. So we know that the probability of A union B is 0.8. So we can automatically pick that the outside, what's not in either of our Venn diagrams, is 0.2. Because it all has to equal 1 eventually. And so if it all equals 1 and the union of the two sets is 0.8, 0.2 is on the outside. Now, if I know that union of the two sets is equal to 0.8, I'm going to find my addition rule to try and find the intersection. So the probability of A union B is equal to the probability of A, add the probability of B, take away the intersection. Running out of room a little bit. Putting my numbers in, my probability of the union is 0.8. That equals 0.5 plus 0.4. Take away my intersection. And it's pretty clear from that my intersection is going to equal 0.1. And then I can fill in the other sets appropriately. The probability of A and just A is going to be 0.4, because that's 0.5, take 0.1. And then here we're going to have 0.3. So now I have my Venn diagram. Of course, if you didn't need this, don't need it, don't worry about it. But now I can easily find the probability of A complement intersection B. Again, this is what is not in A and in B. So what is not in A and in B? Well, not in A is just everything that's not in A, so that's just 0.3 plus 0.2, but it also has to be in B. So it's just going to be our 0.3. Are A and B independent? Remember, if A and B are independent, that means that the probability of A equals the probability of A given B. Well, the probability of A is 0.5. Probability of A given B equals probability of the intersection over the probability of B. And that would give me 0.1 divided by 0.4, which equals 0.25. Therefore, they are not independent. Actually, I'm just going to fix something that I did at the start here. Here I wrote probability of A equals probability of A given B. I'm just going to put this if they are. Because that's not mathematically correct because they're not equal. So I'm going to say, just put it in a hyphen, if they are independent, that is what happens. Well, they're not equal, so therefore they're not independent. All right, so that's the first page. Hopefully you did well on that page, and we'll go through the next page in the next video.